In this video, we're going to talk about the gains from trade. So one of the challenges about thinking about why people trade with each other is that it's very common for people to think about the world as a zero-sum game. And a zero-sum game is a game where if I'm made better off, you have to be made worse off. So the game of poker is an example of a zero-sum game. And in that game, if we both came into the room with, say, $100 and I walked out with $150, then you have to walk out with only $50. So there's a zero sum in terms of the number of dollars that there are in the room. Turns out that a lot of things in this world in which we live in work that way, but a lot of them don't, and trade is one of those things. So what we want to do in this video is think about why people trade with each other, or why people trade maybe with businesses, or why countries will trade with each other. So let's start by thinking about kind of a hypothetical scenario. Let's suppose that you and I are roommates and we both have two tasks that we're responsible for. We have to mow the grass and we have to do homework. And let's pretend for right now that it doesn't matter if I do your homework or if you do my homework. It's just busy work that has to get done. So we're both responsible for mowing grass and for doing the homework. And let's suppose that I'm really good at mowing the grass and you're really good at doing the homework. So for whatever reason, I can mow faster than you and you're better at doing the homework because you go to class, I don't. And so for most people, it seems reasonable that if I focus on mowing the grass and you focus on doing the homework, that both of us can be made better off. There are gains to be had from us kind of specializing in what we're each best at. Let's change it a little bit, and let's suppose that you're better at doing the homework and you're better at mowing the grass than I am. If I were to ask you, are there gains to be had from trading, from you and I trading with each other? You'd probably say, well, it would benefit me if I can get you to take care of some of the things that I'm responsible for, because I'm the one that's not very good at either thing. It would benefit me, but it probably won't benefit you. Turns out that it will. Turns out it's very easy to show that trade will benefit me and trade will benefit you. But because people are so used to thinking about the world as if it's a zero-sum game, that's counterintuitive. And a lot of people have a hard time kind of wrapping their head around that. So what we want to do is talk about this basic principle of economics that people can gain from trade. That's not to say that all trade produces gains. We'll talk about which trades are good for both people and which trades are not good for both people. The way that we're going to approach this problem is we're going to think about two people trading with each other. So let's suppose that we've got two people. We're going to have a farmer and a rancher. So we've got a farmer and a rancher. These two people are going to be producing two goods. They're going to be producing meat and potatoes. And let me give you a little bit of information about how much meat and how much potatoes they can produce. The first thing that we need to think about, we talked about in an earlier part of this class, we talked about production possibilities frontiers, and we talked about when the production possibility frontier is going to be linear and when it's going to be curved, when it's going to be bowed out. What we saw there was that a production possibilities frontier is bowed out if the inputs used to produce each good are specialized. We call that an increasing cost PPF. If the inputs that are used to produce the good are not specialized, then we have a constant cost PPF. We have a linear production possibilities frontier. We're going to assume in this case that the inputs used to produce meat and potatoes, there's only going to be one input. We'll just think about it as time, and it's not specialized. So our production possibilities frontiers will be linear. That makes life easy. So I don't want you to worry about how meat gets produced or how potatoes get produced. I want you to think about it as if the farmer and the rancher, all they have to do is think about production of meat, and at the end of a certain amount of time, there's some meat. Okay? Don't worry about tools or anything like that. So let's think about the number of minutes needed to make 1 ounce. So I'm going to put a table together here. This is minutes needed for 1 ounce. We're going to start with meat here, then we'll do potatoes. And let's put up here the farmer and the rancher. And let's think about how long it takes each of them to produce each of these goods. Let's suppose that it takes the farmer 60 minutes to produce an ounce of meat. 60 minutes per ounce. So it's as if the farmer just thinks about production of meat for an hour, and at the end of that hour, there's an ounce of meat. Let's suppose it takes the farmer 15 minutes to produce an ounce of potatoes. For our rancher, it's going to take the rancher 20 minutes to produce an ounce of meat and 10 minutes to produce an ounce of potatoes. So what we can see is that this is similar to the example I set up for you, where the rancher can produce both meat and potatoes faster than the farmer. So what we want to think about is whether or not there are gains to be had from the farmer and the rancher trading. And again, most people would say, well, yeah, if the farmer, who is less productive, can get the rancher to trade with them, the farmer's going to be made better off. But the question is, can the rancher be made better off by trading with somebody who is less productive than them in everything? And we're pretending as if meat and potatoes are the only two goods in our world here. Okay? What we want to do is change this table just a little bit. Let's suppose that both the farmer and the rancher work for 8 hours. The choice of how many hours to have them work in a particular day is completely arbitrary. We could make this 9 hours or 24 hours. It doesn't matter. But let's treat it as if it's a typical work day. So this is going to be the amount produced in 8 hours. Amount produced in 8 hours. And again, let's do meat, potatoes, for both the farmer and the rancher. So if it takes the farmer an hour to produce an ounce of meat, and they spend all 8 hours of their day producing meat, at the end of the day they would have 8 ounces of meat. Let's do the rancher production of meat. It takes the rancher 20 minutes to produce an ounce of meat. That means in an hour, the rancher can produce 3 ounces of meat, and in 8 hours, the rancher would be able to produce 24 ounces of meat. So these two numbers tell us the exact same story that these two numbers tell us, that if they both work for the same amount of time, the rancher can produce more. It takes the rancher a third the time to produce an ounce of meat, which means if they work for the same amount of time, the rancher can produce 3 times as much. It takes the farmer 15 minutes to produce an ounce of potatoes. That means every hour the farmer can produce 4 ounces, and in 8 hours would be able to produce 32 ounces. It takes the rancher 10 minutes to produce an ounce of potatoes. That means every hour the rancher could produce 6 ounces of potatoes, and in 8 hours would be able to produce 48 ounces. And so we see a very similar story. The rancher can produce potatoes faster than the farmer, which means that if they both work for the same amount of time, the rancher would be able to produce more potatoes than the farmer. So we're going to use these numbers to think about what happens if they trade, but we need to start by thinking about the situation that each of them are going to be in if they don't trade. So let's think about the situation where there's no trade. Neither of them are going to trade with each other. What these numbers give us are going to be the endpoint of the production possibilities frontier for each person. So let's draw the farmers. Let's start with the farmers' production possibilities frontier. And then we'll draw the ranchers' production possibilities frontier. If we were to think about the farmer, and then we'll put the rancher right over here. So let's start with our farmer, and let's put potatoes on the horizontal axis. It doesn't matter. We'll put meat on the vertical axis. You can do it the other way around. As long as you do everything correctly, you'll get the exact same answers. So over here, this is going to end up being our rancher. And for our rancher, we'll also put potatoes on the horizontal axis, meat on the vertical axis. So as long as you do it the same for both of your people, everything will work out fine. So the endpoints are given by these numbers. If the farmer were to produce only meat, the farmer would be able to produce 8 ounces of meat. We'll put that right there. If the farmer produced only potatoes, would be able to produce 32 ounces, so we'll put that right out here. There's 2 points on the farmer's production possibility frontier, and we know that because the inputs are not specialized, the production possibilities frontier is going to be linear. So there's the farmer's PPF. Now we want to pick a place for the farmer to start. Let's suppose that the farmer spends half of the day making meat and half of the day making potatoes. If the farmer spends half the day making meat, then at the end of the day there's going to be 4 ounces of meat and 16 ounces of potatoes. So that point is going to be right there in the middle of that production possibilities frontier. I'm going to call that point A. That's the point where the farmer has 4 ounces of meat, 16 ounces of potatoes. Now, this production possibilities frontier represents all of the possible production points that the farmer could choose to be at, and we've just picked one. It also, if there's no trade, it also represents the possible combinations of potatoes and meat that the farmer can consume. So we can also, if there's no trade, we can think about this as also representing the consumption possibilities for the farmer. We could call it a consumption possibilities frontier. So we're thinking about the farmer producing at point A. The farmer's day looks like this. The farmer wakes up, spends 4 hours of the day making meat, the other 4 hours of the day making potatoes. It can be in any combination. It could be the first hour spent on meat, the next hour spent on potatoes, then the third hour on meat, and the fourth hour on potatoes, and alternating. Or it could be the first 4 hours spent on potatoes and the last 4 on meat. It doesn't matter. As long as 4 hours are spent on meat and 4 hours are spent on potatoes, then that's going to be the combination of meat and potatoes that the farmer has at the end of the day. The farmer consumes the meat and potatoes, goes to sleep, wakes up, and does it the next day. What we know about a production possibilities frontier is that first, it's impossible for the farmer to consume at a point out here. All of these points beyond the production possibilities frontier are unattainable. And we also know that if the farmer one day woke up and said, you know what, I'd like to have some more potatoes than I ate yesterday. The farmer can eat more potatoes than 16 ounces, but that comes at a cost. And the cost is that the farmer is going to have to consume less meat. So the downward slope of this represents the opportunity cost of consuming more of one good. They have to have less of the other. So there's the farmer's production possibilities frontier. Let's draw the rancher's production possibility frontier now. The rancher, if the rancher spends all the time on production of meat, can produce 24 ounces, so that's going to be somewhere up here. And if the rancher spends all the time, all 8 hours on potatoes, can produce 48 ounces, so that's somewhere out here. And we get the rancher's production possibilities frontier. Let's do the same thing for our rancher. Let's pretend as if the rancher spends half of the day making meat, half of the day making potatoes. That's going to put the rancher at a point that we'll also call point A, their initial production point. And at the end of that day, they're going to end up with 12 ounces of meat and 24 ounces of potatoes. That's their consumption point. We can see a couple of things. First off, we see that the rancher eats better than the farmer. There's more meat and potatoes for the rancher to eat, and that's a result of the fact that the rancher is more productive than the farmer. We can see that the rancher, the endpoints of the rancher's production possibilities frontier are out farther than the endpoints of the farmer's production possibilities frontier. And again, that's a result of what we're seeing in this table, that the rancher is better at producing meat and potatoes than the farmer is. So let's think about the amount of meat and potatoes. Let's put together a little table here where we kind of summarize the amount of meat and potatoes that the farmer and the rancher have. Let's put our farmer here, and let's put our rancher here. And let's think about the amount of meat and the amount of potatoes that the farmer has, and then the amount of meat and potatoes that the rancher has. So at the end of the day, if they're not going to trade, the farmer has 4 ounces of meat and 16 ounces of potatoes. So this is with no trade. The rancher has 12 ounces of meat and 24 ounces of potatoes. And let's draw a line here, because what we're going to do now is we're going to allow the farmer and the rancher to trade with each other. So let's suppose now, so day after day, the farmer and the rancher wake up, spend half of their time making each good, consuming the combination of meat and potatoes that we've identified there as point A in each picture. They go to sleep. Neither of them are able to reach a point outside of their production possibilities frontier. And then one day, let's suppose that the rancher goes to the farmer, knocks on the farmer's door and says, "Hey, farmer, look, I've figured out a way that we can change what we produce and then do some trading with each other. It's very simple. We're going to change what we produce, do a little bit of trading, and both of us are going to be made better off." The farmer's probably, as we all would, going to be a little bit skeptical, but let's suppose the farmer sits down and listens to the rancher's plan. And let's think about what the rancher's plan is going to be. So let's put it up here. The rancher's plan is going to consist of 2 parts. The first part is going to be that they're going to change what they produce. Okay, the farmer is going to produce only potatoes. Farmer, only potatoes. So the farmer is going to move to a new production point. Let's identify it. Let's call it, it's going to be right down there at that end point. We'll call it point B. That's going to be the farmer's new production point. The rancher, so the farmer's specializing in potatoes. The rancher is going to, the rancher is going to specialize in meat, but not completely. And we'll talk about why here in a little bit. But the rancher is actually going to move to a point right up here. Let's also call that point B for the rancher. And that point is going to be where the rancher produces 18 ounces of meat and 12 ounces of potatoes. So the rancher is going to spend 3/4 of the time making meat and only 1/4 of the time making potatoes. So let's identify that up here. The rancher is going to produce 18 ounces of meat and 12 ounces of potatoes. So that's the first half of the rancher's plan. Pretty straightforward. The second part of it is that they're going to trade. And so what's going to happen is that the farmer is going to take 15 ounces of the potatoes that the farmer produces and trade them to the rancher in return for 5 ounces of meat. So the trade is going to be 5 ounces of meat for 15 ounces of potatoes. 5 ounces of meat for 15 ounces of potatoes. And the trade looks the exact opposite depending upon whose perspective you're taking. So what's happening here is that the farmer is trading away 15 ounces of meat in return for 5 ounces of potatoes. So essentially the farmer is buying 5 ounces of potatoes and paying 15 ounces of, or excuse me, buying 5 ounces of meat and paying 15 ounces of potatoes. From the rancher's perspective, the rancher is buying 15 ounces of potatoes and paying 5 ounces of meat. It's easy to get your head kind of tied in a knot with this. So there's the rancher's plan. Let's think about now what this plan looks like in terms of this table down here. Okay, so let's think about with trade. With trade. So everything below the line is going to be what is going to happen with this trade. Let's start by identifying production. So the amount of production with trade, well, the farmer is going to produce 0 ounces of meat and 32 ounces of potatoes. So the farmer is specializing completely in potatoes. The rancher is specializing in meat, not completely, but the rancher is going to be producing 18 ounces of meat and 12 ounces of potatoes. So there's what production looks like. Let's talk about the trade. So the trade, from the farmer's perspective, the farmer produces no meat but gets 5 ounces in the trade. So there's plus 5. The farmer's producing 32 ounces of potatoes but is going to trade away 15 of them. So the farmer loses 15 ounces of potatoes. The rancher is giving up 5 ounces of meat in return for 15 ounces of potatoes. So this line, this is just the mirror opposite of that one. Okay, it depends on whose perspective you're looking at it from. Now let's identify consumption. So now, once we've identified the amount that they're each going to produce and the amount that they're going to trade, we can figure out what they've got to consume. So this is consumption at the end of the day. The farmer produced no ounces of meat, but gets 5 in the trade, so the farmer, in terms of meat, has 5 ounces at the end of the day. The farmer produced 32 ounces of potatoes and traded 15 of them away. That leaves the farmer with 17 ounces of potatoes. Let's identify that consumption point right up here on the farmer's production possibilities frontier. So if we look at the farmer's production possibilities frontier, 5 ounces of meat and 17 ounces of potatoes, that's a point right up there. Let's call it point C. That is a production or a consumption point that is outside of the farmer's production possibilities frontier. The farmer could not have achieved that point on their own, but now that probably doesn't surprise us because the farmer's the least productive person here. So the fact that they're trading with somebody who's a lot more productive probably doesn't surprise us that the farmer's able to get outside of the production possibilities frontier. Let's think about the rancher. The rancher produces 18 ounces of meat, trades 5 away. So the rancher has 13 ounces of meat at the end of the day, produces 12 ounces of potatoes, and gets another 15 in the trade. That leaves the rancher with 27 ounces of potatoes at the end of the day. If we were to identify that consumption point, 13 ounces of meat and 27 ounces of potatoes, that's going to be some point out there. What we see is that not only does the rancher get to consume at a point outside of their production possibilities frontier, they consume at a point even farther outside of their production possibilities frontier than the farmer did. So both of them are able to achieve a point outside of their production possibilities frontier. Let's identify down here the gains from trade. So let's just call it gains. So if we're thinking about how much production has increased, which allows consumption to increase, there's 1 extra ounce of meat that the farmer gets to consume, 1 extra ounce of potatoes that the farmer gets to consume, 1 extra ounce of meat that the rancher gets to consume, and then 3 extra ounces of potatoes that the rancher gets to consume. By specializing here, by changing what they produced and then trading, both of them are able to consume a bundle that they could not have produced before or not have consumed before. But not only that, there's now 2 more ounces of meat in the world and 4 more ounces of potatoes in the world. The economic pie has gotten bigger. That's what we mean when we say the world in terms of trade between people and in terms of trade between countries, the world is not a zero-sum game. The economic pie gets bigger so that everybody can have a bigger slice of the pie. What we need to do is we need to think about why. Where do these gains from trade come from? The answer to that question, where do the gains from trade come from? The answer is this. Trade allows each of them to specialize in what they do best. And if I'm in a face-to-face class, what ends up happening is I'll write that on the board. Trade allows each person to specialize in what they do best, and then I'll ask the class, how do you feel about that? And it's always the same. Every time I ask the class, how do you feel about that? Does that make sense? Everybody says, yeah, that makes sense. It sounds good. Trade has allowed each of them to specialize in what they do best. But then I ask the class, well, so in this problem, what does the farmer do best? And then it dawns on them that, well, nothing, right? The farmer does nothing best in this problem. That is exactly how I set the problem up. The farmer is slower at producing meat and slower at producing potatoes. The rancher is better at both of them. So if you just say, okay, yeah, that sounds good, that trade has allowed each of them to specialize in what they do best, you're kind of forgetting that we've set this problem up in a very particular way to illustrate a point. So what we need to do is we need to think about what it means to do something best, because it is true that each person is specializing in what they do best. It is true that the farmer is better at producing potatoes than the rancher is. But what we need to do is clear the board off here and then kind of think very carefully about what it means to do something best. So let me clear this off and then we'll sort that out. So understanding where the gains from trade come from in this problem relies on the ability to understand what it means to do something best. If you think back to the discussion that we had early on in the class, we were talking about opportunity cost. And one of the examples that I talked about was the opportunity cost of going to class. And if I ask an introductory class, what's the opportunity cost of coming to class today? Most people will say, well, it's 50 minutes. I have to spend 50 minutes in the room. And then that kind of starts to get to the answer, but the answer really isn't the number of minutes. The answer is, what's the other thing that you could have been doing if you weren't in class? So what would you be doing in the 50 minutes? So the minutes, the number of minutes, is just kind of an intermediate step. And so if you think about what we've done here, That table that I had over here at the beginning, that table showed us the number of minutes needed to make an ounce of each of the good. And by focusing on those minutes, we're focusing on something that we shouldn't. That's not really the cost. The cost is, what's the thing that you can't be doing? If you're doing this good, what's the other thing that you can't be doing? It doesn't matter how many minutes. And that's really hard for students to kind of wrap their heads around, because we're used to competing with each other. If you had a brother or a sister, it's probably the case that you guys competed with each other in terms of maybe how fast you could run, or how much you could eat, or time was always something that was used to compare yourself with the other person. And it's not until you get into an economics class that somebody like me tells you the number of minutes doesn't really mean what you think it means, at least not in the case of what we're talking about here. What we want to know is who actually produces meat and potatoes more efficiently. And it doesn't matter the amount of time. The key here is that if you're going to produce more potatoes, that's time that you can't spend producing meat. So it doesn't really matter the number of minutes that are in between there. It's how much less meat you have to produce if you're going to produce another ounce of potatoes. So the key here lies in understanding the difference between what economists call absolute advantage and comparative advantage. So absolute advantage, let's talk about the definition of that. Absolute advantage has to do with how fast you can produce something. A producer has an absolute advantage over another producer if they need less of the input to produce a unit of the good. Another way to think about that is a producer has the absolute advantage over another producer if, in the same amount of time, they can produce more of the good. So what we have here is a situation where the rancher has the absolute advantage in production of potatoes and the absolute advantage in the production of meat. You can see that from the tables that we talked about, because the number of minutes needed to produce an ounce was smaller for the rancher than it was for the farmer, for both goods. You can also see it from the production possibilities frontier, because the endpoints of the rancher's production possibilities frontier are farther out than the farmer's. So that's telling us that the rancher has the absolute advantage. But that's not what we need to focus on, because absolute advantage deals with just the number of minutes needed to produce. We need to think about what economists call comparative advantage. A producer has the comparative advantage over another producer if they have the lower cost of production. So what we need to do is we need to think about what's the actual cost of production. If the farmer's going to produce one more ounce of potatoes, how much fewer ounces of meat are they going to be able to produce now? Same with the rancher. If the rancher wants to produce one more ounce of potatoes, how much meat do they have to produce? We're going to think about the intermediate step of how much time gets used up in production of potatoes, but only to figure out how much less meat they can produce. So let's think about what that's going to look like. Let's start from the rancher's perspective. And we're going to go through some steps of logic here. Once we get through this and we see how it works, we're going to think about a faster way to do this. So in terms of solving problems, what I'm about to do here is only to teach you why it works the way it does. Once you get get your head wrapped around it, we won't be doing this to solve problems. There's a quicker way than what I'm about to do, but we need to do this. It takes the rancher 10 minutes to produce an ounce of potatoes. I erased that table, but if you look in the notes that you're taking right now, and you should be taking notes, if you look back in those notes, you'll see that it takes the rancher 10 minutes to produce an ounce of potatoes. So let's write that out. Takes the rancher 10 minutes to produce an ounce of potatoes. 1 ounce of potatoes. That is 10 minutes that can't be used to produce meat. So let's write that out. Here's step one. That's 10 minutes that can't be used to produce meat. So here's where we get to the actual cost. How much meat could the rancher have produced in 10 minutes? In 10 minutes, remember it took the rancher 20 minutes to produce an ounce of meat. So in 10 minutes, the rancher could produce a half ounce of meat. In that 10 minutes, the rancher could have produced 1/2 ounce of meat. And now we've got what we need. The cost for the rancher of producing that ounce of potatoes is a half ounce of meat. This 10 minutes is just an intermediate step. That you need to use it, but it's these two numbers that matter. So what we can get from this is, for the rancher, the opportunity cost of 1 ounce of potatoes is 1/2 ounce of meat. Now let's think about that for a second. If you think back to when we were first talking about production possibilities frontiers, we spent some time talking about the fact that the slope of the production possibilities frontier tells you the opportunity cost of the good on the horizontal axis. The reason I started here with potatoes was because I've got potatoes on the horizontal axis. So what we've just found out is that the opportunity cost of an ounce of potatoes is a half ounce of meat. For the rancher, if we were to go over here and look at the rancher's production possibilities frontier, if you look at the slope of that thing, the slope is constant because it's a line, and the slope here, the easiest way to figure out the slope is to look at the rise and the run that corresponds to the endpoints of this thing. The slope of this thing is 24 over 48, which is equal to 1/2. That's not a coincidence. We're just seeing exactly what we talked about in that previous video, where the slope of the production possibilities frontier tells you the opportunity cost of the good on the horizontal axis. So we don't really, once you understand that point, you don't have to go through all of this, starting here and going through these steps to get to that. If you want to know the opportunity cost of an ounce of potatoes, just look at the slope. It's 1/2 ounce of the other good, which is meat. If we look at the slope of the farmer's production possibilities frontier, the slope here would be 8 over 32, which is equal to 1/4. So what we see is that the opportunity cost of an ounce of potatoes is smaller for the farmer than it is for the rancher. The farmer is actually better in terms of their cost of production. The farmer is better at producing potatoes than the rancher is. One thing that I need to point out here, a common mistake that I sometimes see in my principles class, is that when you're thinking about the slope of this production possibilities frontier, you're taking this number and dividing by that number. It is just a coincidence that this number divided by that number is also 1/2. That's just because we've chosen that particular point. If you did try to do that with point B and looked at that number, which I believe was 18, and divided that by 12, the coordinates of that number, you would not get 1/2. So don't just pick a point and divide the vertical coordinate with the horizontal coordinate. That's not how you calculate the slope. You've got to look at the rise and its associated run. Same thing over here. 8 divided by 32 is 1/4. 4 divided by 16 is also 1/4, but that is just because that point is right there in the middle of that thing. So don't just divide some coordinate with another coordinate. Look at the endpoint. Okay? As long as you divide this endpoint by that endpoint, you're always going to have the right answer. So now we can see that the farmer has the lower opportunity cost for production of potatoes. And that's what it means to have the comparative advantage. a producer has the comparative advantage over another producer if they have the lower opportunity cost. And in this case, the farmer has the lower opportunity cost for production of potatoes. What we want to do now is think about putting a table together. So when you solve problems with these types of problems, it's very important that you be methodical about how you solve them. One thing that you need to do is put this table together. Put together a table that shows the opportunity cost of, let's start with potatoes because that's the one that we've got on the horizontal axis, and then we're going to do meat. So the opportunity cost of an ounce of potatoes, we've just figured out for the, let's put here the farmer and then our rancher. The opportunity cost of an ounce of potatoes for the farmer is 1/4 ounce of meat. I'm just going to say 1/4 meat. It's in terms of ounces. And the opportunity cost of an ounce of potatoes for the rancher is 1/2 ounce of meat. A lot of times what I'll do is circle the smaller one, just so that when I go back to look at it, it's obvious what I'm looking for. 1/4 is less than 1/2. So the farmer has the comparative advantage in production of potatoes. Let's think about production of meat. Who has the comparative advantage in production of that? Well, turns out that the opportunity cost of the good on the vertical axis is given by the reciprocal of the slope. So if you want the opportunity cost of meat, all you have to do is flip over the slope. So you just take the reciprocal of these numbers. For the farmer, the opportunity cost of an ounce of meat is 4 ounces of potatoes. And for the rancher, the opportunity cost of an ounce of meat is 2 ounces of potatoes. And again, 2 is less than 4. So we've just seen that the opportunity cost for production of meat is lower for the rancher. That's why the rancher specialized in production of meat. And clearly you can see that because these numbers are reciprocals of these numbers, the smallest one over here, the person with the smallest opportunity cost in this column, is going to have the bigger opportunity cost in that column. What you get here is that it's not possible for one person to have the comparative advantage in production of both goods. That's important. Over here we've seen that one person can have the absolute advantage in production of both goods. The rancher did in this problem, but in terms of comparative advantage, it's not possible to have the comparative advantage in production of everything. The other side of that coin is that it's impossible for you not to have the comparative advantage in something. Okay? So if you've identified that the farmer has the comparative advantage in production of potatoes, you immediately know that the rancher has the comparative advantage in production of meat. But again, I would make sure that you always put this table together because this is how you solve these types of problems. So the gains from trade come from each person specializing in the good for which they have the comparative advantage. So I'm going to put here, saying that somebody has the comparative advantage. That is equal to saying that they have the lower opportunity cost. If you have the comparative advantage, you have the lower opportunity cost. What's going on here is that we call it comparative advantage because you are comparing their opportunity costs. Okay? What we need to do now is talk about the range of, so in this problem, I gave you the trade, 5 ounces of meat for 15 ounces of potatoes. What we want to talk about is where did that come from? Because a natural question you might be asking is, well, so how do I figure out the trade? I mean, if I were to ask you, give me a trade that would work, that would make both of these better off, we need to figure out how you would approach that problem. So I'm going to clear a bunch of this stuff off, and then we'll take a look at how to figure out which trades will work. All right, let's think about the range of prices at which gains from trade exist. So I've got the opportunity cost table up here. We can identify that the farmer has the lower opportunity cost for production of potatoes, rancher has the lower opportunity cost for production of meat. But let's think about which trades would work. Once we know that, that tells us who's going to specialize in which good, but it doesn't tell us which trades will work. So let's take a look at the what I'm going to call the price implied by the trade. And it depends on whose perspective we're taking. Price implied by the trade. Let's think about the farmer's perspective first. So if we start with the farmer got 5 ounces of meat for 15 ounces of potatoes. So let's write that out. Got 5 ounces of meat for 15 ounces of potatoes. Let's think about how much each ounce of meat cost for the farmer. Okay, so that means that each ounce of meat costs 3 ounces of potatoes. So we could rewrite this. Let's say let's not say each, let's say 1 ounce of meat for 3 ounces of potatoes. That's how much each ounce cost. The way I did this was to use that kind of golden rule of algebra. If you're going to do something to this, you've got to do it to that. If I want to turn 5 into 1, I need to divide 5 by 5. That 5 over 5 is 1. But if I'm going to divide that by 5, I need to divide that by 5 also. 15 divided by 5 is 3. So the farmer got each ounce of meat for 3 ounces of potatoes. And let's think about why that makes the farmer better off. The reason that makes the farmer better off is because that price that the farmer paid, each ounce of meat cost the farmer 3 ounces of potatoes. That falls right in between the range of the opportunity cost for the farmer and the rancher. So remember, the farmer here is buying meat. If the farmer produced meat themselves, it would cost 4 ounces of potatoes for each ounce of meat, but the farmer is able to buy it for 3 ounces of potatoes. Buying meat is cheaper for the farmer than producing it themselves. So the farmer's happy about that trade. In terms of the rancher, is the rancher happy? Well, of course, because the rancher is selling each ounce of meat for 3 ounces of potatoes, and it only costs the rancher 2 ounces of potatoes to produce each ounce of meat. The rancher's selling it for 1 more ounce than it cost them to produce it. So the farmer's buying it for 1 less ounce than it would cost them to produce, and the rancher's selling it for 1 more ounce than it cost them to produce. Both of them like this price. And so any price that fell in between that range of 2 and 4 would create gains from trade. In a face-to-face class, I always will ask the class, how many numbers are there between 2 and 4? And there are always a handful of people that say there's only 1 number between 2 and 4. No, there's not. There's 1 integer between 2 and 4. But there's an infinite number of numbers between 2 and 4. Numbers like 2.5, 3.1, 2.793. So this one's nice and simple. 3 falls right in the middle there. But there's an infinite number of prices that would create gains for trade between the two of them. There's also an infinite number of numbers that lie outside of this range. So in terms of what's going on there, you just need to pick one in the range. There's an infinite number of them. Let's look at this from the rancher's perspective. So the rancher got 15 ounces of potatoes for 5 ounces of meat. So if we want to know how much each ounce of potatoes cost the rancher, we need to divide this by 15 to turn it into 1, but then we've got to divide that by 15. 5 over 15 is 1/3. So this is the same as saying got 1 ounce of potatoes for 1/3 ounce of meat. If you think about why this trade, and this trade is just the mirror image of that one. That's why this number and that number are reciprocals of each other. But if we look at it from the rancher's perspective, the rancher is getting each ounce of potatoes for 1/3 ounce of meat, and that creates gains from trade because 1/3 falls right in between 1/4 and 1/2. Okay? So the same thing is happening here. The farmer is selling potatoes, is able to produce each ounce of potatoes for 1/4 ounce of meat and then sell it for 1/3 ounce of meat. The farmer's made better off. The rancher likes to get potatoes this way because if the rancher produces 1 ounce of potatoes, it costs them 1/2 ounce of meat. They can get it in the trade for only 1/3 ounce of meat. So both of them like it. And you should be able to see that any trade that implies a price that falls in that range is also going to imply a price that falls in this range because this range is the reciprocal of that one. So now you understand, hopefully, why this trade creates gains from trade, because it implies a price that falls right in between the two opportunity costs. What we need to do now is clear this off, and then I want to work through one problem from beginning to end. It takes a while to kind of go through all of these steps and talk about logically why one thing leads to another, but when you actually solve a problem with a two-person trade problem, it's actually fairly quick. So let me clear this off and then we'll take a look at a problem. Let's take a look at what a problem is going to look like. One of the problems with the farmer-rancher example is that sometimes the students think that the farmer specializes in potatoes because I've called them the farmer. And that's not the case. I could call them just person A and person B. And the rancher specializes in meat because they're a rancher. So what I need to do is give you a problem where the name of the person or the name of the country doesn't tell you anything about what they might specialize in. As a matter of fact, I could go back and change that problem to where the farmer specialized in meat and the rancher specialized in potatoes. That would be very easy to do, but I don't know, that creates some confusion for students. So let's take a look at a different problem. And this time, let's use two countries. So let's suppose that we have the U.S. and Mexico. And let's suppose that our two countries each can produce two goods. Let's make them food and computers. And let me give you the information for how much food and computers the U.S. and Mexico can produce if that's all they produced. So the way that I can give you this there's lots of ways to provide this information to you. We could do it in terms of how we did the farmer-rancher problem, where I could tell you how many minutes it takes to produce a unit of food and how many minutes to produce a unit of computers, and then tell you how much time they're going to work, and we could go through that. Let me give it to you kind of in sentence form. I'll write a sentence here and then I'll kind of quote from it, but let's suppose if the U.S. produces, let's say, only food, it can produce, let's say, 400 units. Let me move that over here. It can produce 400 units. If the U.S. produces only food, it can produce 400 units. If the U.S. produces only computers, I'm going to abbreviate that there, it can produce, let's say, 100. The U.S. produces only computers, it can produce 100 computers. If Mexico, let's start with food, produces only food, let's suppose Mexico can produce 300 units. And then if Mexico produces only computers, let's suppose they can produce, say, 20. So we're not going to worry about how long it takes to produce food and computers and how much they work. I'm just going to give you the endpoints of the production possibilities frontier there. So the information in a problem could be provided to you a number of different ways. Another way I could provide it is just to show you the production possibilities frontier. So there's multiple ways. Let's go ahead and draw the production possibilities frontiers for the U.S. and for Mexico. So let's put the U.S. here. Let's put food on our horizontal axis, and we'll put computers up on our vertical axis for both the U.S. and Mexico. Here's computers, food, here's Mexico. And so these numbers that I've given you are just the endpoints of the production possibilities frontier. We're going to be assuming, like we did with the farmer-rancher problem, that the inputs used to produce these two goods are not specialized. Now, I realize that with food and computers, in the real world they would be specialized. But when we're working problems here, I want it to be as simple as it can be for you. So let's draw the production possibilities frontier for the U.S. If the U.S. produces only food, it can produce 400 units. So the endpoint of its PPF is going to be right there in the food direction. If the U.S. produces only computers, they can produce 100. So there's the other endpoint. Inputs are not specialized, so we get a linear production possibilities frontier. If Mexico produces only food, they can produce 300, so there's the endpoint for Mexico in the food direction. If Mexico produces only computers, they can produce 20, so that's going to be somewhere down here. Also, their production possibilities frontier is linear. Looks a little curved, but pretend that's a line. So now we've got the PPF for the U.S. and Mexico. And I could ask a few questions about, at this point I could ask about absolute advantage. So I could say which country has the absolute advantage in production of food. Well, there's a couple ways you can answer that. You could look at whose endpoint is out farther. The U.S.'s endpoint is out farther in the food direction. You could also just look at the table. If they produce only food, then the U.S. can produce 400 units, Mexico can only produce 300. So you can get the answer from either the table or from the picture. It's also the case that the U.S. has the absolute advantage in production of computers. They can produce 100 compared to Mexico's 20. So with just that information, about all I can ask you is who has the absolute advantage. Let's talk about the opportunity cost. And for the opportunity cost, we're going to put together this table. So let's talk about the opportunity cost of, let's start with what we've got on the horizontal axis, 1 unit of food. And then we're going to do it for the U.S. and we're going to do it for Mexico. And then once we've got this column, we're going to do 1 unit of computers. I always, when I put the table together, my first column is always the good on the horizontal axis because it's just the slope. That's the easiest. So for the U.S., the opportunity cost of a unit of food is equal to the slope of this production possibilities frontier. The slope of this thing is 100 over 400. So the slope of that thing is 1/4. It's 1/4 of a computer. If we look at the opportunity cost of a unit of food for Mexico, you have to be careful with this one because when I ask students in a face-to-face class to calculate the slope, sometimes they accidentally say that it's 2/3. They accidentally think 200 over 300, but it's 20 over 300. 20 over 300, we can knock off one of those zeros. That's equal to 1/15. So the opportunity cost of a unit of food in Mexico is 1/15 of a computer. So if we're thinking about who has the lower opportunity cost for production of food, it's clearly Mexico. They only have to give up 1/15 of a computer, whereas the U.S. would have to give up 1/4 of a computer. Mexico is better at producing food. If we want this column, all we have to do is invert these numbers. So for the U.S., the opportunity cost of a unit of computers is 4 units of food. And for Mexico, the opportunity cost of 1 unit of computers would be 15 units of food. And so clearly the U.S. has the lower opportunity cost for production of computers. So now that we've got that table put together, then you can answer a variety of questions about who has the comparative advantage, who's going to specialize in which good, who's going to export which good to each country. So let's identify a few ways that I could think about asking you questions here. One is we could just talk about who has the comparative advantage. I could just directly ask you who has the comparative advantage in food and who has the comparative advantage in computers. Well, in terms of food production, you just look at the food column and you can see that Mexico has the comparative advantage in production of food. In terms of computers, it is the U.S. that has the comparative advantage in production of computers. What that means is, if we were thinking about specialization, who's going to specialize in which good? Specialization, you're going to specialize in whichever good you have the comparative advantage in. So the U.S., let's start with food. Mexico has the comparative advantage in food, so Mexico will specialize in food production. In any problem that I give you, we're going to think about them specializing completely. In the farmer-rancher problem that we did, the rancher did not specialize completely in meat. And you might ask, well, why? I mean, why did the rancher move up towards the meat endpoint but not all the way? Well, I'm not 100% sure. That problem comes from the textbook by Mankiw, and I'm not 100% sure why Mankiw didn't have them specialize completely in production of meat, because the gains from trade would have been even bigger. I think it's probably because the numbers work out a little bit nicer, but in any problem that I give you, I'm going to have you have the person for whom they have the comparative advantage in, say, food, have them specialize completely in food. So in terms of computers, the U.S. will specialize completely in production of computers. So if I were going to identify the production points up here, Mexico is going to specialize completely in food production. There will be their production point. And the U.S. is going to specialize completely in production of computers. So there will be their production point. This corresponded to point B in our other example, in the farmer-rancher example. There will be the production points that each country is going to produce at. Another thing that I could ask is I could say, who's going to export food, who's going to export computers? Well, clearly, Mexico is going to export food because the U.S. isn't producing any food. Only Mexico is producing food. And the U.S. will export computers because they're not producing anything except computers. So who's going to export? I could ask that question in terms of who's going to import. But again, once you know who's going to specialize in which good, that's an easy question to answer. I could ask about total production. Let's call it total world production of, let's start with food and then do computers. So if I were going to ask you, suppose these two countries trade. What's going to be total world production of food? Well, Mexico is going to be the only country producing food, and they're going to produce 300 units. So there will be 300 units of food produced. And the U.S. is going to specialize in computer production. They can produce 100 computers. So total world production of food is going to be 300. Total world production of computers is going to be 100. This is usually the point at which students start to, they get betrayed by their brain and they start to say, but wait a second. Total world production of food is 300 units, but if the U.S. produced food, it could produce 400 units. So maybe the U.S. should produce food because they can produce more. But what's happening there is your brain is going back to thinking about absolute advantage. And what we've seen here is that absolute advantage does not create gains from trade. It's comparative advantage. It's each country or each person specializing in the good for which they have the comparative advantage. So when you get to this and you see that there's a number in that table bigger than some of these numbers, don't get sidetracked by that. Another example or another type of problem that I could ask about this is I could say, what's the range of prices? Range of prices. So let's suppose I ask you, what's the range of prices for food? No, let's do it for computers. For computers. Range of prices for computers at which both of the countries would agree to trade. Well, all you have to do is pick any trade that implies a price between 4 and 15 units of food per computer. So the range of prices for computers would be anything between 4 and 15 units of food. So for example, one computer for 10 units of food. That would be a trade that would work because one computer for any number in between there, one computer for 9.32 units of food. That would be a trade that would imply gains. If I ask you for the range of prices for food, then you would think about any trade that implied a price between that range. And you might ask, well, in the real world, how does the price get figured out? Well, if you just had two people, it would be up to those two people or these two countries to negotiate with each other. What we'll see is, in our next chapter, we'll talk about demand and supply, and we'll see how prices, when there are lots of buyers and sellers, how prices get determined. But here, if you've just got two, it'd just be up to the U.S. and Mexico to negotiate some price. So whichever country was better at negotiating, they might be able to push the price more in their favor than in the other countries. But any trade that implies a trade, or any trade that implies a price between those two numbers is going to create gains from trade. So let me show you one other thing. We could use this to write, let's say, one computer for anything between 4 and 15 units of food. There's a homework problem that I will have you do, and sometimes I put a problem like this on the test. Let me put a line here to kind of differentiate what's going on here. There's a homework problem where you have to do something like this because they're going to ask you, what about a trade of 7 computers or 20 computers? What would be the range here? Well, the key to answering any problem like that, if they don't ask you, if I don't ask you about one computer, what if I ask you about what's the range of prices for 20 computers? Well, what you would do is write this sentence, one computer for anything between 4 and 15 units of food. And I'm getting every one of those numbers right here. 1 unit of computers for anything between 4 and 15 units of food. Or if I ask you about food, it would be 1 unit of food for anything between 1/15 and 1/4 of a computer. If you then want to turn that into something other than one computer, like let's say it would be 20 computers, for anything, you just multiply these numbers by 20. So it would be anything between 80 and 15, 20, 300. 20 computers for anything between 80 and 300 units of food. That would create gains from trade. So if you want to put it in terms of something other than 1 unit of food or 1 unit of computers, just write that sentence and then multiply everything by the number. Okay? So that gives you hopefully an idea of what problems would look like. This problem, even working through the problem, because I showed you all of the different things I could ask, that takes some time. But working through a problem, creating that table, that's really the key to this type of problem. Working through it doesn't take a lot of time. As long as you're comfortable interpreting the numbers in that table, as long as you do a good job of being careful about drawing these production possibilities frontiers, these numbers these answers are pretty easy to get. So that gives you hopefully an idea of where the gains from trade come from. It's not absolute advantage, it's comparative advantage. It's comparing the actual opportunity costs. That's the opportunity cost represents the actual cost of production. So I will see you in the next video.